Today we're going to look at section 2.4, which is about more on slope. Our objective today, we're going to find slopes and equations of parallel and perpendicular lines. Parallel lines are two non-intersecting lines that lie in the same plane. So let's talk about the relationship between slope and parallel lines. If two non-vertical lines are parallel, then they have the same slope. So they're increasing or decreasing at the same rate. That's what makes them not intersect. If two distinct non-vertical lines have the same slope, then they are parallel. So essentially, I'm just flipping that first statement around. So if you know you have parallel lines, that's because they have the same slope. If you have two lines with the same slope, then you know that they're parallel. If you have two distinct vertical lines, both with undefined slopes, they're going to be parallel. So let's look at an example. It says, write an equation of the line passing through the point -2, 5, and parallel to the line whose equation is y equals 3x plus 1. We're going to express the equation in point-slope form as well as slope-intercept form. So let's start with our point-slope form. Okay, in order to do point-slope form, which remember is y minus y1 equals m times the quantity of x minus x1, we need to have a point, we need to have a slope. We actually have all of that. We have our point right here of -2, 5, because remember, x1, y1. And then because they're telling us that we're dealing with a parallel line, if the equation is written in slope-intercept form, notice that my slope is 3. Well, we just talked about the fact that parallel lines have the same slope. So I'm not going to have to change that number. 3 is my slope. So that's my m. So I have everything to substitute it in. So we're going to have y minus 5 equals 3 times the quantity of x minus -2. Because I have back-to-back negatives, I'm going to simplify that. So we'll still have y minus 5 equals 3 times the quantity x plus 2. So there's my first answer. They're also asking us to write the equation then in slope-intercept form. So remember that is y equals mx plus b. So we already know what the slope is. We already know that the slope is 3, but we don't have a point that represents the y-intercept. So the fastest way for us to do that is, now that we have the point-slope form, let's just simplify this and get that to say y by itself. So I'm going to have to distribute the 3. So that'll give me 3x plus 6. And then I'll add the 5 to get the y by itself. So y equals 3x plus 11. There's my slope-intercept form. All right, let's talk about perpendicular lines. These are two lines that intersect at a right angle. So what's the relationship between slope and perpendicular lines? Well, if two non-vertical lines are perpendicular, then their product of the slopes is -1. So then flip it around. If the product of the slopes of two lines is -1, the lines are perpendicular. But how do we know that the product is -1? What's the relationship there? Well, essentially, here, this one too. A horizontal line having 0 slope is perpendicular to a horizontal line having an undefined slope. Hopefully that makes sense. Perpendicular is where they form right angles. If you have a vertical and a horizontal line, they're going to intersect perpendicularly. Okay, so essentially what I was trying to get at with the first two steps here, because the product is going to be -1, that's because the slopes are opposite reciprocals of each other. So an example, oops, no. Get back to my pen, sorry. So an example of this would be if I have a slope of 2, Then the opposite would be a negative because this 2 is positive. Reciprocal would then be flip it around. If 2 is really 2 over 1, then 1 over 2 is the reciprocal. So opposite means 1 is positive, 1 is negative. If I multiply those together, I'm going to get negative 1. All right, so let's go ahead and take a look at an example. So it says, write the equation of a line passing through the point -2, -6, and perpendicular to the line whose equation is x plus 3y minus 12 equals 0. We're going to write it in slope-intercept form and then in general form. So the fact is I have my point. So if we're talking about, well, if we want slope-intercept form, we need to have a slope, we need to have a y-intercept. Honestly, in order to do that, because we're given a point, we're going to have to do point slope form first to get it into then slope-intercept form. Okay, notice that we are given a general equation here, and so I'm going to take this general equation that I just highlighted here, and I'm going to manipulate that into slope-intercept form so then I can identify the slope. So the fastest way to get the y by itself, if it's in general form, is to move the y over to the other side. So we'll have x minus 12 equals negative 3y. I'll divide every single thing by negative 3. So y is going to equal negative 1/3 x plus 4. All right, so the fact that I have this allows me to identify the slope. But remember, we're talking about a perpendicular slope. So negative 1/3 is not the number that I'm going to use in order to actually solve my problem. The slope that I want is the opposite reciprocal. So since this slope is negative, the slope I want is to be positive. Flip the 1 and the 3 around, and so the slope that I really need to use is 3. So I have my point of -2, -6. I now have my slope of 3. I'm going to put it into the slope point slope form. So we'll have y minus -6 equals 3 times the quantity of x minus -2. Well, back-to-back negatives, it's really y plus 6 equals 3 times the quantity x plus 2. So now to get this into the slope-intercept form that I really want, I'm going to distribute. So we'll have y plus 6 equals 3x plus 6. I'm going to subtract the 6. And so we get y equals 3x. You could put plus 0. You don't really need that. Here is my slope-intercept form. So if this is slope-intercept form, okay, now the last thing they're asking for is general form. So to get it into general form means that I need to take that equation and I need to get it all to one side to make it equal 0. So I'm going to leave the x positive, so I'm going to subtract the y over to the other side. So really 3x minus y equals 0 is my general form. All right, so it says write the slope-intercept equation of a function f whose graph satisfies the given conditions. We have the graph of f passes through the point -1, 5 and is perpendicular to the line whose equation is x equals 6. So if we're talking about wanting to write a slope-intercept equation, obviously we need a slope, we need a y-intercept. They're giving us a point that is not a y-intercept. But if they're telling us that we have a line x equals 6 and we want a line perpendicular to it, hopefully we remember that if I have x equals a number, this is a vertical line. And so how do you make a vertical line have a perpendicular line to it? Well, that line has to then be horizontal. So here I need to have a horizontal line, which means that I need to have, y equals a number. But if I just have y equals a number, that means that my slope is really 0. If I have a horizontal line, my slope is 0. So I'm going to use the point slope form because I have a point and now I have a slope. So I'm going to have y minus 5 equals, we've got my slope of 0 times x minus negative 1. Well, y minus 5 equals 0 times the quantity x plus 1. Obviously, if I distribute 0, I'm going to be multiplying the whole entire thing by 0, and I get 0. So y minus 5 equals 0. So add the 5 over, and notice that y equals 5 is going to be the equation that is perpendicular to the line x equals 6, but also goes through the point negative 1, 5. And hopefully that makes sense, because remember, we're talking about my y-intercept has to be 5 if I have this horizontal line here, and notice that y is 5 in that point as well. It also says to write the equation as a function of f. So y equals 5. I'm going to write it in function notation. So f of x equals 5. All right, so here's another one. So we're going to write the slope-intercept equation of a function f satisfies the given equation. So it says the graph of f passes through the point 3, negative 8, perpendicular to the line that has an x-intercept of negative 3 and a y-intercept of 9. Okay, so if we have an x-intercept of negative 3, that means we have the point negative 3, 0. If we have a y-intercept of 9, that means we have a point 9, 0. I'm going to use those 2 points to find my slope, because then once I find the slope, I need to then have a slope perpendicular to it. So to calculate the slope of those y-intercepts and x-intercepts, I'm going to then make this x1, y1, make this x2, y2. I want to subtract the y values, put that over the differences of the x's. So we're going to then have 9 on the top, 3 on the bottom. So 3 is my slope. However, that's not the slope that I want. I want a slope that is perpendicular. So opposite reciprocal, the number that I really want is negative 1/3. All right, so now that I have that, I am going to use the information of the point that I have. Okay, so I'm going to ignore that that's x1, y1 there, because this is now what I'm going to use the point slope formula. Okay, so we're going to have y minus negative 8 equals negative 1/3 times the quantity of x minus 3. So I really have y plus 8 equals negative 1/3 times x minus 3. We want to get it in slope-intercept form, so I'm going to distribute the negative 1/3. So y plus 8 equals negative 1/3 x, and this will now be plus 1. And then I'll subtract the 8 over to the other side. That gives me y equals negative 1/3 x minus 7. Okay, but once again, I am going to then write it in function notation. So f of x equals negative 1/3 x minus 7. So there is my line that passes through the point 3, negative 8, and it's perpendicular to the slope that we just got from the x and the y-intercept. All right, so here's another one. It says a linear function that models data is described. We're going to find the slope of the model, then we'll describe what it means in terms of the rate of change of the dependent variable per unit change in the independent variable. So it says the linear function f of x equals 0.01x plus 57.5 models the global average temperature of Earth, f of x, in degrees Fahrenheit x after 1995. So if they're asking us to identify the slope, well, we have it in slope-intercept form. So hopefully right away we're okay with noticing that 0.01 is going to be the slope. So now I want to describe what that means in terms of this model. So once again, the model is talking about the global average temperature of Earth in degrees. So we're talking about a positive slope. So the temperature of Earth is increasing by 0.01 degrees Fahrenheit each year. And I guess this has been since 1995. So there's my little explanation using the information from the model. So I would like you to pause. You're going to write an equation of the line in point-slope form and in slope-intercept form. So two different checkpoints here. So I'm giving you the point 2, -3, and I want it perpendicular to the line whose equation is y equals 1/5 x plus 6. And then I also want the point -1, 3 to be parallel to the line whose equation is 3x minus 2y minus 5 equals 0. Okay, so for the first one, we're talking perpendicular. So if 1/5 is the slope of that equation, opposite reciprocal gives me the slope that I really want. So then point slope form simplifies that y plus 3 equals -5 times the quantity x minus 2. Distribute the -5 and solve for y to get y equals -5x plus 7. For the second one, I'm talking parallel. So once I took that general form and wrote it into slope-intercept form, the slope that I identify is the slope that I want to use. So then y minus 3 equals 3/2 times the quantity x plus 1. There's my point slope form. Distribute the 3/2, add the 3, and that gives us y equals 3/2 x plus 9/2 for our slope-intercept form. So that's us finding slopes and equations of parallel and perpendicular lines.